Thank you. After the last presentation, I have to stick to the second largest flood. But I will talk about a similar thing and from a similar period, but much less space and narrower terrain with a similar flood. So I will talk about the Jutulhogget canyon in Norway. Jutul means troll, and hogg means cut. So the local language is the troll's cut. So we have branded this as a canyon formed by disastrous flood by the end of the last ice age, as similar to the last presentation. My co-authors, Fredrik Høgås, also at the Geological Survey of Norway, he has been contributing with the final new science to make this the final pieces in the puzzle. Geographic location in the east central Norway, in the mountain areas, and what we may see is that, first of all, this is a canyon, and it's formed in schistose meta sandstones. So these are rocks with very defined, regular fracture systems. And that is a part of the picture. And what we see here is blind end. You have no rivers or anything coming into this, so it just stops. And it's draining eastward, and draining eastward in Norway is not very common. All the glacier drainage in Norway was towards the south, west, and northwest. So the geological context of this is a bit similar, like the last one. It's the last period, the last part of the ice age, the last ice age. So 10,000 years ago, the ice sheet covering Norway, there was an animation here, but I think that is not working now, had retreated to the interior part of Norway. Meltwater was trapped between local spillways and a remnant ice sheet, and you get these enormous glacial dammed lakes. So one of these lakes, we call it the Nedre Glomsjø Lake, was a huge lake covering this area. It was remains of the ice sheet here. And at some stage here, the ice collapsed, could not longer keep the water there, and we get like a 90 to 95 meter deep, 2 kilometer wide flood wave. And this event is dated to 10,500 to 10,300 years ago. So at its largest, this lake kept a water volume of 140 cubic kilometers. So the geological description, the Jutulhogget Canyon is the most prominent and impressive landform shaped in this catastrophic event. But the story also contains glacially dammed lakes in the region. It contains the enormous deposit of debris near the canyon mouth and the sedimentological evidence of catastrophic floods downstream from the remnant ice sheet. So above the canyon, we see all these remains from the glacially dammed lakes with shoreline features, deltas, etc. And we can see this very clearly on LIDAR data where you have these shorelines, old shorelines here. The canyon itself is about 2.5 kilometers long, and the width is 150 to 500 meters, and the depth is 240 meters. And I had a little joy that that was a double of the 122 from the last. But this is a very concentrated effect of when the dam broke. You can see some people here, there. So about 100 cubic kilometers was drained in a matter of days. And below the canyon, beneath the canyon, you have this, I should call it the king of debris flow. It's a huge scree deposits at the canyon mouth. And you will find stone blocks as tall as houses scattered around in that area, all moved by running water. And then, these are the most interesting from the latest research, is that you, in a way, you looked with new eyes on the sedimentations along the downstream rivers and see if you can connect these more to the big flood. And that we did, or Fredrik Høgås did, where you have these enormous flood bars that you can see downstream the rivers, and a lot of features that was previously interpreted as aeolian dunes, were similar type of dunes that you described from the US, the flood dunes. So there are much new evidence on how to see the catastrophic effects downstream. So 2.4, yeah, you would not be there when this river was full of icebergs and debris and 100 kilometers an hour. Scientific tradition. This was discovered, of course, quite early in the mid-1800s and described by a geologist Ruysch in 1878, where he asked more questions about this. He was curious, but it had no answers. Was it water or ice shaped, late ice age or after, or even before? What he did consider was that this was different geologically than other landforms in Norway. So Jutulhogget, it deviated from the expected patterns with the eastern drainage and the blind end. So much discussion, and it's about a bit of the same. It's difficult to accept these big events. So there were a lot of discussion throughout the years. Open lake or not, short catastrophic event or not. Finally, we got the new research, and now it's widely accepted that this is a large glacially dammed lake emptied by a vast flood that formed Jutulhogget and deposited outburst flood deposits far south along the river. So main arguments: Jutulhogget Canyon, together with its head, or the glacially dammed lakes, and tail, the catastrophic downstream flood, tells the story of a catastrophic geological event following the Ice Age. Process behind this is now well documented and scientifically published, and the geological record related to the development and drainage of the early Holosok glacial lake is very much visible and allows for unprecedented documentation of these fascinating events. So we have, I will end with the mythological version of this. A troll, Jutul, envied his neighbor Valley Troll for having a bigger river and carved a canyon with his axe to lead the water over to his own valley. But the neighbor got angry and killed the intruder before he could finish the cut. This is the last, and this is some of the publications we have used. I will also add that we had this campaign for the news in Norway on Monday, this event. It fairly quickly reached the national media, and Monday afternoon I got a phone call from the municipality where you have this canyon, and they said, is this really so important? Is this really so cool? And now we have already been invited to the management plan of the area, because this is a protected area, but mainly for biotopes. So now we have been invited to introduce geoconservation into the further management planning of this. So we have a very concrete effect for this nomination already. Thank you.
Thank you very much. Any questions or comments? There is one, yes, please. Just wait for the microphone, please. Yeah.
So how do you go about calculating water volumes involved in these kind of feature development?
Can you
How do you go about calculating the volumes of water that would have been involved in development of these kind of features?
that is, I cannot answer much on that. That is my colleague, Fredrik Høgås. He did this modeling together with some others, and that this is to be found in one of these publications. So, but it's interesting, and I think it's very valid how they did it. Of course, in these days, the LIDAR data has been enormously important for quaternary geology mapping in Norway, and in a way, how you can, you get also much more better models when you use these detailed data, and yeah.
Thank you. And another one.
Hi, I've got two comments. The first one, I remember reading the submission to start with, and now having seen this background, I understand it far, far better. I can appreciate it much more. And I think for every site that we have a role to write up and publish a larger description of each site. Sometimes that information is elsewhere, but we should find a good format to do that. For example, in episodes, the IUGS journal, or another way. The other point is that I remember seeing a very similar feature in Iceland from a Jutulhogget, a glacier outburst due to volcanism, and also in Canada from the Mount Miga volcano, which has created landslides and floods as well. So we obviously have a series of events which have a similarity around the world, which is up to the geomorphologists to inventory, and that could eventually form a part of a larger group of, shall we say, equivalent sites around the world. And that is the same for almost every one of these sites we've presented. Each of them has equivalents elsewhere which have comparable values that we should look into. Thank you.